I always wanted to make a PS1 styled renderer with modern lighting techniques and different features, but I didn't want to use a bloated existing game engine, nor an existing framework that does all the heavy lifting. Not because they are bad options, but because I like to suffer and make stuff by my own. So I decided to use the easiest graphics API, OpenGL, and here's what I managed to do. For this I use C99, SDL3, CMGUI, CGLM, and Glue. With the latest OpenGL version. It doesn't really change much since OpenGL is pretty backwards compatible, but it does give you useful functions that help you reduce GPU calls and make OpenGL a bit more like Vulkan. It also adds SSVOs, which are bigger than UVOs, HLSL support, and of course this project uses the Meta build system for building the project. But first let's start off with my humble beginnings. Like everyone, I used Learn OpenGL as my main resource. I had already learned the basics of OpenGL in the past, so I went through the basics pretty fast. First triangle, textured shrinking cube, spinning square, rotating cube, swings, rotating texture cube without GL enabled depth test, and other kind of accidental stuff that was a happy incident. Then I got to lighting, which gave everything a bit more life. I added funk shading combined with diffuse and specular lighting, and created some scenes to test the lights. It was very fun to implement, and here I realized about my love for shaders. Finally, I managed to load models with their proper reflections, shininess, and material settings. I learned about the depth buffer, which I used to make this effect in the Sponza model, and about spotlights, which are pretty useful for making flashlights. Here's an example of a metro scene. I also added fog, which is very PS1 style, to avoid rendering further tiles. It adds some sense of mystery and horror, and it works both at night and evening. Adding transparency to windows was also very simple and looks pretty good. And I also created my fair share of post-processing shaders, which look terrific in their own way. I made some simple optimizations, mainly making less GPU calls. So I cached shaders to not bind already used ones, gathered uniform locations on a hash map, and I did around the same thing with BOs, PVOs, and EVOs. I also moved reused uniforms to SSVOs, so all the shaders can access them. This was surprisingly one of the things that I struggled with the most, because I did not understand how memory layout looks in the GPU. In CPU code, usually you have 32 to 64 bits, and they're 8-byte aligned or 4-byte aligned. Meanwhile, on the GPU, they are 16-byte aligned. So this leads to weird padding issues that you have to solve yourself. So instead of looking like this, it would look like that, since you have to add the padding yourself. I don't want to talk about it anymore, so I will let myself of the past explain it at 4 AM going through a mental breakdown.
To add another one and get 16. And then I need to make sure that the total value for this struct is a multiple of 16, of course. For example, here, you see that I just added 4 bytes, so I need to get to 16, so I need to add another vec3. Or I could add an F4, an F4, an F4 to get 16 in total. Such a mess, look.
Anyways, after all this suffering, I added better debugging with ImGUI for seeing current state of things and copying values, as well as a GL macro for checking errors after running each GL call. I made a scene loader for handling lights and objects a bit simpler, and very simple OpenGL abstractions, which made the renderer very nice to use. I also extended GLSL and added includes, which help reuse code. And to make shader development more streamlined, I added a hot reloader for shaders, which makes faster iterations with shaders possible. So there is no need to recompile the entire project again. You can just press F5 and it recompiles the changed shaders. Overall, I think I learned about most of what there is to learn about OpenGL, since it's a pretty simple API. Though my engine is still missing a ton of simple optimizations, particle system, tile system, some simple physics and collisions, text rendering, etc. But it's not really complex stuff. Though, what I still feel like I'm missing in terms of knowledge/skill is writing shaders. I still find it hard to understand 100% of what is going on, as I'm missing important math concepts like linear algebra, trigonometry, calculus, and other advanced math topics. Luckily, today's sponsor can help with that. Brilliant is very good at teaching you pretty much all the math concepts necessary for graphics programming. You'll finally learn what vectors and matrices even mean in the context. But it goes further than that. It allows you to choose from a vast array of topics, where you can get from beginner to advanced in, for example, math, computer science, and even physics, with thousands of interactive lessons which will help you tremendously to get started with the daunting graphics programming field. With Brilliant, you get smarter every day, which is very necessary as a programmer. Its lessons help you build your critical thinking skills through problem solving and not memorizing, which is a very effective way to actually learn topics. So to try everything for free for a full 30 days, visit brilliant.org/Lewowski or scan the QR code on screen, or you can click in the link in the description. You'll also get 20% off an annual premium subscription. I didn't go over everything I did in my renderer, mainly about abstractions, so in the description I left a link to the repo for the curious. Also, I'm thinking on starting to do YouTube full time, thanks to all the support I've been getting. So if you want to support me, I added YouTube memberships to my channel. They give you some silly emotes and an icon that changes depending on the amount of months supporting, and gives you a special role in my Discord where I make updates about videos and what I'm working on. So if you want to help me pay my groceries and want to know what I'm doing for my next video, consider becoming a member.